Alright guys, welcome to Unit 2 on measurements. We're going to start this out by talking about what chemistry is and a little bit about matter. So you should have read a few pages in the textbook that talks about what chemistry studies and different fields within chemistry, and here's where we're going to talk about the matter and the change. So let's start this off with what is matter. This is kind of a review from middle school and elementary school. It's anything that has mass and takes up space. So basically, anything that you can touch is something that has matter. It has properties or characteristics that are intrinsic to the type of matter that you're talking about. So iron matter will have certain qualities unique to iron. Hydrogen matter will have qualities unique to it. There are 4 different forms or 4 different states: solid, liquid, gas, and plasma. There technically are a lot more forms than that, but for the purposes of this class, without getting into some hardcore physics, this is all we need to worry about. So solids have definite shape and volume, and the particles are packed very tightly together. Usually they're very closely associated with their neighbor particles, so you don't have a lot of movement occurring within a solid. Liquids, the particles are still close together, but they're not really associated with each other, so they can flow and move over each other pretty freely, but they still conform to the shape of their container and they have a definite volume. Gases have almost no association with each other, so they can expand to fill any volume or any shape and actually be compressed down to very small volumes as well. Plasmas are a gaseous state, so they're like a type of gas, but they contain free electrons and positive ions. And what that means is essentially they have positive and negative charges moving around in this gas. Some examples are lightning and the aurora borealis, or the neon lights and fluorescent lights that you see. Those contain plasma. Now with gas, you may have heard the word vapor as well. Now, vapor is used to describe something that is normally solid or liquid at room temperature that we've turned into a gas, like water vapor. Whereas the term gas is the term for a substance that is a gas at room temperature. Kind of just splitting hairs, but in case you're curious or if you're trying to figure out the right word to use. So a few more, I guess, basic definitions before we move on. I'm going to be using the word substance. All that means is it's a form of matter with a definite and uniform composition. And what I mean by composition is its makeup. How is it made? So all parts of the substance are made from the same element or the mix of elements. They can be an element, a compound, or a mixture. And we'll get into what those 3 are. So substance is essentially like saying stuff or things. It's a very general term. Now, a mixture is 2 or more substances that are physically combined, and we'll kind of get into what we mean by physical and chemical combinations in this PowerPoint. So it can be mixed elements, mixed compounds, things like that. So an example would be the atmosphere. We have a lot of different mixtures of gases in the atmosphere. It's not just one gas that makes up the air. Another example that's pretty easy to see and understand is like salad dressing, or like a soup with a lot of vegetables in it. It's a mixture of different things and you can see what they are. Sometimes with chemical mixtures you can tell all the different parts and sometimes you can't. There's elements. These are the simplest form of matter, but they still contain all the properties of that type of matter. So it's like saying, how small can I make iron so that it still has all the properties of iron? If I make it any smaller than this, it's not really iron anymore, it's something else. Some examples, like I said, are iron, hydrogen, oxygen. A compound is a substance with two or more elements that have been chemically combined. So they are actually interacting on a chemical level, and they're creating a whole new substance that's completely different from what they came from. So, for example, I can take hydrogen and I can take oxygen, which are both gases at room temperature, and I can chemically combine them to make H2O, or water, and that's a liquid at room temperature. It created a whole new substance from those two. So if you see the picture on the left, you have red substances and blue substances. They are saying these are two different elements. You can put them together in a mixture, like down here, and you can see they're in the same space together, but they are not actually chemically interacting. There's just red and blue in the same area. Now, this next part, you see they've actually combined chemically to make a whole new compound, a whole new substance. That's the compound version of this. Now, going back to some of these properties of matter, we're going to start out with two different ones, extensive and intensive properties. An extensive property, it depends on the amount of the substance. So it's a property that can change if you have more or less of whatever substance you're talking about, something like mass or volume or length. An intensive property, you think of it as something that's part of what this substance is. It's identity. So intensive, you can think I for identity, or it's integral, it's part of it. So it's an inherent quality that is independent of amount. Something like the color, whether I have 10 grams or 5 grams, it's going to be the same color. The boiling point and the melting point, whether I have a drop of water or a bucket of water, the boiling point is still 100 degrees Celsius. Molecular weight, density, these are all things that are intensive properties. They're independent of how much you have. Now, the other two properties of matter are physical and chemical properties. A physical property is an inherent characteristic that can be observed, measured, or used to describe the substance. So something like color, or density, or the melting point, or hardness, things like that. A chemical property is more of like what it could be. This is the potential of the substance to undergo a chemical reaction or to change into a different type of substance. Something like flammability or combustibility. Now, for physical properties, let's go over some of these in detail. I don't think I really have to go into melting point, freezing point, boiling point, but sublimation is one you may not have heard before. This is where the point where a solid will skip over the liquid state and just go automatically to gas, like dry ice. Dry ice is frozen carbon dioxide, so it's solid carbon dioxide. And at room temperature and pressure, it doesn't become a liquid, it just automatically switches over to gas, and that's why it's giving off all that smoky substance. Malleability is a physical property, so it's changing a substance's shape using pressure. So you can like squeeze it down and change its shape, or you can hammer it and turn it into a thin sheet. This is often common with metals. You also have ductility, where I can stretch it and pull on it and turn it into like a wire or a strand. You have hardness. Now this is more of like a comparison property. So if I can take a substance and scratch another substance, that first one that did the scratching is harder than the one that got scratched. You can be conductive. This is your ability to conduct or move electrons, conduct electricity. You can be soluble. That means you can be dissolved by another substance, or you can be the solute, something, or the solvent, I'm sorry, something that does the dissolving. Polarity, this is where your substance will have an uneven charge within the element or the molecule, so it'll be positive or negative. Density, how compact or condensed is your matter. Magnetism, can it create a magnetic field? And then the things that are kind of self-explanatory, like color and odor and things like that. Now, a physical change is any change to these physical properties that we've talked about of the substance. It doesn't change what the substance is, it just changes some of its physical characteristics. So if I took a piece of gold and hammered it down into a sheet, it's still going to be gold, it's just going to have a different shape. So these can be reversible or irreversible. I can melt ice into water and then refreeze it back into ice. Sometimes you can't do that. It just depends on what type of change you're making. So some examples of physical changes: cutting paper, creating a mixture, separating a mixture, changing the states of matter, so going from solid to liquid or liquid to gas or back and forth from those. Dissolving a substance. So if I put sugar in my iced tea, the sugar will dissolve, but it's still sugar and tea. It doesn't become a whole new thing. Anytime you see the words breaking, crushing, cutting, splitting, grinding, separating, melting, boiling, freezing, condensing, and sublimating, all of these are clues that some type of physical change is occurring. So moving away from physical characteristics, let's talk about mixtures for a minute. There's two different types of mixtures: a homogeneous or homogeneous, or a heterogeneous or heterogeneous. I've heard both ways of pronouncing it. So with a heterogeneous mixture, this is where the composition or the makeup is not uniform throughout. So whatever mixture you have, it's not equal. You may have more of some substance in one area than another. Something like a chicken noodle soup, or oil and water is a pretty good one. You can see how they separate. It's a mixture, but they don't like being close to each other. They don't like mixing evenly. So in these types, you're going to have two or more what we call phases. So if you take the oil and water example, you can see two distinct phases: a water phase and an oil phase. Now for homogeneous mixtures, this is where the makeup is going to be uniform or the same. The substance is going to be perfectly evenly mixed. Something like salt water. You don't go into the ocean and have a taste of the water and be like, oh, this tastes fresh, and then I move 5 feet to the right and it tastes salty, because that's where all the salt is. No, it's evenly mixed. It's also called a solution. So a homogeneous mixture can be called a solution if you prefer. This is where you only have one phase. You can't tell one substance apart from the other in the mixture, so it looks like one whole unit. A way to remember these, if you go back to what you learned in biology class, hetero means different and homo means the same. So heterogeneous, different mixtures; homogeneous, it's the same. It looks like one. So here's some examples. So for heterogeneous, you've got mixed nuts, oil and vinegar, a salad where you can see all the individual parts that are different. But in a homogeneous mixture, something like sugar water, you don't see the sugar once it's been dissolved into the water. You don't see the orange particles and the water particles. You just see orange juice. You don't see the different proteins and sugars found in milk. You only see milk itself. Now, there's two methods that we can use to separate these mixtures, because sometimes you want part of a mixture but not the other part. So the first one is filtration. And if you guys make coffee at home, you are using a filter every day to separate a mixture. So this is a special material. It's often paper with holes that are large enough to let some materials through, but not others. It's selectively permeable, if you remember that term from biology as well. So with this, we're separating out large particles and letting smaller particles get through. Usually this is used to separate a solid from a liquid, something like when you're making coffee. I don't want the coffee grounds in my coffee, I just want the liquid in there. Now for distillation, this is good when you have a homogeneous mixture and it's really hard to separate those out, or they're both liquids mixed together. You can boil off one substance and then take all that gas that's been boiled off, cool it off in a different place so it condenses back down into its liquid form. So if you're looking at this setup in the image, we have a mixture in this flask here, and we're going to boil it. And because different substances have different properties, they're probably going to have different boiling points depending on what substances are in this mixture. So one will start to boil and turn into a gas, and we direct all the gas into this tube that's separate from the original flask, and we start to cool it down. So it gets a little cooler now, away from the heat. And as that happens, it turns into a liquid that we can then collect. So as I said, this is a really good way to separate mixtures that are homogeneous or that are both liquids. So a chemical property is, like I said, the inherent potential of a substance to undergo a chemical change. So let's actually get into what that looks like now. So some chemical properties is the substance flammable, meaning can it catch fire and burn? Is it combustible? Now, flammable and combustible kind of seem like they're interchangeable. Combustible, we tend to use it more in terms of explosion. In industry, they say flammable means we're at normal temperatures and it can catch fire easily, whereas combustible means it has to be really, really high temperatures. Corrosive is anything that will destroy by eating away or weakening a material. So rusting and oxidation, that's a type of corrosion where oxygen is reacting with the metal and causing the metal to actually turn into a different substance, and it makes the metal weaker. If something is reactive, that means it easily combines or reacts with other substances. Something can be radioactive, where the atom itself is actually decaying and releasing other substances or energy. Something can be toxic, meaning it has a dangerous or poisonous quality that interferes and interacts with living things' chemicals. Or something can be stable. It doesn't react with its surroundings. That in and of itself is a chemical property, the fact that it has a hard time interacting with other things chemically. So what are some examples of chemical changes? Well, chemical changes are anything that produces matter with a different composition than the original matter that you started with. So if I start with wood and I add a burning match to it, I'm going to end up with ash and carbon dioxide gas. So I've created different elements, elemental mixtures in the end. So this is actually changing one thing into another. It's not like a phase change at all. With a phase change, when I take ice and let it melt, it's still H2O, it's still water, it's just in a different state. This would be like actually turning the water into something else. So something like cooking, making alcohol through fermentation, letting metal rust, explosions, burning, fermenting, decomposing, all of these things describe chemical changes. I made a mistake there in the PowerPoint. This is a chemical change. So there's a few clues that'll help you recognize when a chemical change has occurred. The first one, energy has been transferred. So I can tear a piece of paper and there's no real evidence of a transfer of energy there. But there is when I'm actually doing a chemical change. There's energy that's needed for a chemical reaction to occur. Sometimes energy is also even produced from these reactions. The second clue is you might see a change in color. So you might have two clear liquids that when you mix them, they turn green. The third is production of a gas. You may see bubbles starting to form. Now this one, sometimes bubbles are just evidence of a phase change, like boiling. So this one is not conclusive on its own. You'll often have to pair it with a different clue or with weight measurements to see in the end, has my substance converted into a different substance. The last one is the formation of a precipitate. And a precipitate is just any solid that forms and settles out of a liquid mixture. So you may mix two liquids and all of a sudden you'll have a solid start to form inside the liquid mixture. Sometimes it can look like there's a little bit of dust on the bottom of your container. Sometimes it looks like actually an example from real life is like the soap scum that'll build up around your shower, like a soap ring. They can be any size, any shape, any color, but those are the 4 clues to recognize chemical changes. Now, chemical reactions, I've used this term a couple times. It's essentially the fancy way of saying a chemical change has occurred. So it's when any chemical change turns one substance into a different one. Now, the substances that go into the reaction that start are called reactants. They're what the reaction needs. The things that are made in the end are the products, which makes sense. So an example that you guys might have talked about in biology is this equation right here at the bottom. This is a chemical reaction. CO2, water, and sunlight. These are my reactants, the substances that are going into my chemical equation, my chemical reaction. And then the arrow means they're becoming, so the reaction is occurring. And my products are glucose and oxygen. So this is the photosynthesis equation. So these 3 are my reactants, and these 2 are my products. I start with these and end with these. So the last thing we're going to talk about is the law of conservation of mass. Now, whether I'm doing a physical or a chemical change, my mass is always going to be conserved. What that means is it's not created, it's not destroyed. No matter what I'm doing, the mass that I start out with is going to be the mass that I end with. So this is a scientific law. It's a statement of fact supported by lots of evidence. And we actually are going to do some of these tests throughout the year where you will see what you start with is what you end with. They weigh the exact same amount, no matter what kind of change occurred. All right, and that is the end of this lecture. I hope you guys liked it. If you have any questions, write them down and come prepared for class, and I will go over them then. Hope you have a good one.